The flat earth model had a big problem, a very big one, and I think we solved that problem.
How many of you think that the flat Earth model doesn't make sense because the sun would never rise and set, but instead be visible 24 hours a day? Welcome to the Steve and Dr. Zach Show.
Now, if you ask any scientist about his opinion about the flat earth, he will ask you this: how do the sunrise and sunset work on the flat earth model? And the flat earther will answer, perspective. Well, that is not enough. I mean, perspective is just a little part of the answer, but it's not enough. So the scientist here debunks the entire model with one question. That was my only problem ever since I started to study this flat earth model. I knew it was not the only reason why the sun disappears the more it moves away from us, And 15 months ago, I started to work on this with Chandra Seke, aka The Man, and then we teamed up with Steve Torrance, and together we solved this puzzle.
The answer was always in front of us. We just didn't see it like fish don't see the water. Now we can model it and understand the flat Earth model more than ever before.
Now let me summarize the story for you. At the beginning, we thought about something that we could add to perspectives to understand how the sun works, because we were sure that perspective was not the only reason why the sun disappears behind the horizon line, but we were not sure if our theory would work, and we had no idea how to test it. Steve already had a flat earth model designed in his software, but there was something missing from it, and this something was the atmosphere. And we had no idea how to add this atmosphere to his model, if you know what I mean. If you take a look at any animation of the flat earth, the atmosphere is always missing. It's like drawing the flat earth in a vacuum of space. And this is why the sun never sits on the flat earth, because there is no refraction. Now my question is, have you ever seen an animation of the globe earth model with the effect of the atmosphere? I'm not talking about just drawing the clouds or the air. It's not just drawing them. It's how to make them work as they do in real life. You know what I mean? They know how the refraction works and they know how the atmosphere works, but they never add it to their animation, And if they do, the sun would never sit as they claim it does. And we can prove that too.
Modern science claims that the apparent sun sets after the real sun because of the atmosphere and the effect of refraction. So when we see the apparent sun above the horizon line, that is just a reflection of the real sun, which is already set. But when we added the atmosphere to the globe model, it did the same thing that it did on the flat Earth model. The apparent sun goes down first, and the real sun follows it. That is contrary to the way refraction is normally presented.
So the atmosphere is something that we can't ignore. It's like looking at the sun with your glasses on. The atmosphere is like a lens with no cover. We are like fish in the sea, So the atmosphere can change the whole view of the sun. Now, in order to prove this, we had to add the atmosphere to Steve's model, but the question was how? It was not an easy thing to do, and by coincidence, Steve found out that his program is capable to model the atmosphere exactly how it is. So he took the data from the internet and built all the layers of the atmosphere, and suddenly the magic happened and everything started to make perfect sense. And when I say everything, I mean everything. The sun started to rise and set, and it started to match reality more than the globe model does.
With 3D software, you can model the atmosphere very accurately using refraction settings. We're not talking about drawing it and making it visible, we're talking about drawing the layers with their real effects on sunlight. Once I discovered it, I told my team, guys, we've got a solution. We can test the atmosphere's effect on the light.
After we had everything fixed, we started to compare it with real life. We actually took some real sunset videos and compared them with both the flat Earth model and the globe Earth model. And guess what? If you play the 3 videos at the same time, you would not know where the flat Earth model is, because it really looks like real live videos.
Many scientists think that the flat Earth model can't work because it can't represent sunrise and sunset. What are they going to say after studying this proof? Is it going to make sense to some of them now? They can't ignore the atmosphere, and all we did to make the flat Earth model work was add the atmosphere exactly how science represents it. We didn't make it up.
Now, solving this problem doesn't mean that we solved everything. We still have a problem with the elevation angles, because the sun that we see is not in its real position. What we see is just the apparent sun. So imagine the real sun is here and the fake sun is here. The shadow that you're gonna get is going to follow the apparent sun and not the real sun, and this is not what we want. Okay, so the elevation angle that you're gonna measure with the sextant or with any other tool is not the angle of the real position of the sun. It's just the angle of the apparent sun. And we're still working on how to locate the real sun that we never see. Once we locate it, we will be able to get the exact elevation angles of the real position of the sun. And by doing that, we can draw the flat Earth map from scratch. I couldn't continue drawing the flat Earth map with the triangulation method that I talked about a few months ago, if you remember, because I found out that I was triangulating the fake position of the sun. So triangulating the sun from 3 different positions is like triangulating 3 suns at the same time, and that will never ever give you a precise number. So that is why I stopped plotting the map, and right now I'm just focusing on how to locate the real position of the sun.
When the sun is directly overhead, the refraction is near 0, but you still can't say where the sun actually is. As the sun travels towards the west, the atmosphere creates an image of it for every eye. So anyone who looks at the sun from the same angle as you, but from a different city, will see the apparent sun in a different position. But no one can see the sun in its real position. So if you try to triangulate the sun, you will never get the exact distance. This is like trying to triangulate a rainbow. This is how the sunrise and sunset started to work on the flat Earth once the atmosphere was added. In the description you will find a link to the original video. Compare it with this one and make your own conclusions.
We were planning to do an experiment to back up our theory, and Chandra Seke, or the man, was supposed to do it because he had what we needed, but because of the problems of life we had to postpone everything. But we will do many videos about this subject because it's the key to solve everything.
Thanks for watching.
Hi Flat Earthers, this is Zach.
And this is Steve. In the previous video, we gave you an introduction on how the refraction in the atmosphere, or the atmosplane, was the solution to the various visual problems that were not working on flat Earth models. If you haven't watched that video yet, click on this link to watch it now.
Today we're going to explain a little bit more by showing you the star trails from different locations on the flat Earth. Many people thought that the video we showed before was not enough to prove that refraction is the reason why the sun rises and sets, and many others thought that refraction would make the apparent sun appear higher up instead of down. So to make this clear, let me tell you that what we did was add the atmosphere to the flat Earth model in Cinema 4D. And Cinema 4D made the apparent sun go down, not us. So if there is anything wrong with this, then it will be Cinema 4D's fault. If you disagree with the software, please send them an email and see what they will tell you. Now picture the sun is above you and the last layer of the atmosphere or atmosplane is a lot closer to you than the sun. The refraction will happen until the last layer of the atmosplane, which goes to the ground, right? So looking at the sun from the ground through the atmosplane can make the apparent sun appear lower instead of higher. And if you look at it this way, the apparent sun will appear higher, right? But this is all incorrect. What you will see from the ground is the apparent sun only. So whether it appears here or there, it is always lower, and the real sun is always higher. Now the question is, what makes the sun go down as it moves away from you? There are a few theories about this, but they can all be wrong. But let us explain one theory. If the atmosphere plane is only 5 miles up and the apparent sun is right above it, then yes, perspective can make the sun go down in less than 7,000 miles away from the observer. And this will make the flat earth model work. But you and I believe that the atmosphere plane or atmosphere is a lot thicker than that, therefore perspective will help a little, but not a lot. So if the real sun moves to the west for about 4,000 miles, how would the apparent sun look like from the observer's perspective? We can guess, but we will not know until we make a physical experiment that represents all of this. For example, we can do this in a big swimming pool to see how a refracted bulb will look like from far away, in order to see both refraction and perspective in action. If you guys can help, please contact us and let's prove this scientifically. But for now, let's just call it a theory. Because we're just trying to prove it in a 3D program. I'm pretty sure we are correct, but let's just call it a theory. Here is how the real sun and the apparent sun move in Cinema 4D. It's acting exactly how we expected. The apparent sun appears to move faster than the real sun, therefore it disappears in less than 7,000 miles away from the observer.
When the apparent sun is at 0 degrees, the real sun is at 35 degrees. And as the real sun rises at its normal speed, the apparent sun follows at a higher speed. The more they rise, the closer they get, and when they are 90 degrees, the refraction is 0.
This is a diagram I made in AutoCAD with the real elevation angles of the sun that we get from suncalc.org. This is the location and dates that I used. You can try that yourself. So when we draw the angles accurately, we notice that the sun travels faster the more it moves away from the observer. As you can see, the distance between 5 and 6 p.m. is a lot longer than the distance between 4 and 5 p.m. And the distance between 12 and 1 p.m. is very close to the speed of the sun on the Tropic of Cancer. On the globe model, you can say it's the speed of the spinning Earth in the Tropic of Cancer. But of course, the apparent sun doesn't travel in a straight line like the real sun does. So the distance between each hour should not be so exaggerated. We can draw it like this, but this is nothing but a diagram. And by the way, if perspective is the reason why the sun sets on the flat earth, then the more the sun moves away from us, the slower it should appear to us, right? Imagine yourself in the middle of a highway. The cars that pass by you will be moving in their real speed. But as they move away from you, they look like they are slowing down. But that doesn't happen with the sun, right? In fact, the sun appears to travel faster the more it moves away from you. So perspective is definitely not the only reason why the sun goes down.
Here is how the star field would look if we removed the atmosphere plane. The place is Canary Islands, Spain. The lens that I used here has a 122 degree field of view, and as you can see, the stars never set because they are too high for perspective to make them rise or set. Their altitude now is about 4,000 miles. This number is fairly accurate and matches the rise and set times shown in the programs such as Stellarium. Now I am going to play the same video, but with the atmosphere or atmosphere plane added. As you can see, the video has changed completely and the star trails look exactly like the original picture. Here is the original, taken on March 15, 2015. Now let's play the two videos side by side so you can see the effect of the atmosphere plane. We can do this from any location, they all work the same. And here is another test in France. Look at it carefully and compare it with the original, and let us know if we're doing anything wrong. And here is how the sun rises and sets in Salinas, California. We still need to make adjustments to the height of everything, but the atmosphere already makes them rise and set correctly. The atmosphere was the key to solving the puzzle.
This is a quick view of the stars in AutoCAD so you can understand how we drew them in Cinema 4D. All the stars you see on the model are 4,000 miles up, and the angles of the stars are accurate and they match modern science. We didn't make them up. And that Excel sheet on the left side of the screen shows all the data that we used. You can find it in the description. Here is a south view of the stars on the flat Earth with the atmosphere plane added. Now this should be enough for some trolls to see that wherever we are on the flat Earth, the sun and the stars will rise and set. And if they don't look like real life, then please try to understand that by adjusting the map and the height of all the objects in the sky can fix the problem. We still don't know for sure the heights of everything, and we still don't know for sure how the real map looks like. The point is that the atmosphere or atmosphere plane makes everything in the sky rise and set in Cinema 4D. If you think that the atmosphere should make things go up instead of down, then please talk to Cinema 4D programmers.
Here is something that we're going to talk about in the next video. When the atmosphere plane was added, the first thing that we noticed was that spheres looked oblong when viewed through the refraction. The only way to overcome this was to make the spheres as flat as possible. For the moon, it could not be perfectly flat, or the phases would not work. So the moon is a very flat sphere, or almost flat, but not 100%. Don't forget to subscribe to my channel, Steve Torrance, where you will find complete versions of the clips shown. I will also be doing more videos this week showing views from various locations. Thanks for watching.
Hi Flat Earthers, this is Zach. In the last two videos about refraction, we talked about how the sun and the moon and the stars rise and set on the flat Earth by just adding the atmosphere to the model. A lot of people thought that it was great, but some people said that we contradict science and therefore our model is incorrect. And I did it like that. Of course, when people know that you don't belong to the scientific community, they automatically think that you are stupid. So I decided to make a small experiment and show the world that we are not stupid. And we don't contradict science, it's just them who don't understand science. Please, if you didn't watch those two videos, go back and watch them now so you can follow me here. They said that if the sunlight bends because of the atmosphere, then the atmosphere will make the apparent sun look higher than the real sun, and not lower as we did, and therefore the sun will never set. I tried to explain to them that it wasn't us who made the sun appear lower or go down behind the horizon, and that it was a program called Cinema 4D. But they kept on saying the same thing over and over again. So, in this experiment we will know if the apparent sun should look lower or higher. So let's do some science. On this table I have water that represents the atmosphere and light that represents the sun. 3 points where I'm gonna place the object, and here is the object. The distance between each point is 20 centimeters. There is nothing important about these numbers for now. I'm doing it like this just to study the angles of refraction over distance, but right now you don't need to care about them, but I'm gonna show them to you anyway. The object is 10 centimeters long. The bottom of the object is 3 centimeters in diameter, and the top is 2.5 centimeters. The distance between the light and the table is 39 centimeters. I drew this in AutoCAD yesterday before the experiment, and I drew my expectations of the real and refracted shadow based on some calculations that I've been working on for the last month. And now we're gonna find out if they are correct. But let me show you what I expected to see. So as you can see, I drew the same thing that you saw on the table, and I expected the shadow of the object to act like this, with and without refraction. First, I'm gonna explain this to you, and then I will show you the results of the experiments. So stay with me. What I did was draw a lamp and 2 objects, and I also drew their shadow in relation to the source of the light. And on the same shadow of each object, I added another shadow that should be caused by refraction. According to these people who think we are lying, the shadow after we add the water should be shorter instead of longer. But my head told me that the shadow would look longer. And that means that refraction makes the source of the light appear lower and not higher. So the first shadow of object A before refraction was 8 centimeters. So I calculated that if we added the water, the shadow would be 9 centimeters and not 7 like these people think. And I did the same thing with object B. And the first shadow of object B was 14 centimeters. So after refraction, you might think it would be 15 centimeters. Or 13 centimeters if you still think like these people. But I think that it should be longer than 15 centimeters because the distance is longer. So the shadow after we add the water, of course, would be even longer. Because water will lower the apparent light. So the shadow that the apparent light is going to cause will be longer than that. So I expected it to be 19 centimeters. So let's do the experiment to make sure if I am saying the truth. So I'm gonna put the objects in position A and put the water under the lights and mark the tip of the shadow with my finger so we can see the difference. Now I'm gonna remove the water so the shadow can go back to its place. As you can see, the shadow without refraction is shorter. The refraction makes the shadow longer, and that means that the water makes the apparent light lower instead of higher. Is it because of the glass? I don't think so. Right now, I don't have the equipment to do it with water only. If you have it, then do it. In either case, we win because many people say that there is a dome. So, let's move the object to position B and do the same thing. I don't know if you can see it from there, but there is a bigger difference here. I measured all the shadows after filming the experiment and I got the same result as I had in AutoCAD. Now the question is, did the glass make the shadow look longer, or did the water and the glass make it longer? As I said before, I don't know, I don't have the equipment to know, but I emptied the plates from water and tried it to see if the glass without water would make the shadow look shorter instead of longer. But the shadow is still getting longer, and the difference is very, very small. Then I tried it with a flat glass only, and it did the same thing. Look at the shadows, it's getting longer. And again, a longer shadow means that the apparent light is lower. Then I added the 2 glasses together and they did the same thing. The shadow is still getting longer. Then I added water and covered it with that flat glass, and the shadow is still longer than the real one. The laser tests that people do with glasses to see refraction are correct, but this is not a laser pointer that is pointing towards a particular object. This is a bulb, and the sun is doing something similar, so maybe this is why people are confusing the two things. I tried it with the laser, and the shadow did become shorter. It was hard for me to film, but I think you already know that. I pointed the lamp to the object, and the shadow did become shorter. But it doesn't work the same when you use a round bulb. That is the difference. Please don't believe me, do it yourself and make your own conclusions. Thanks for watching.